In mathematics, the large sieve is a method in analytic number theory. Its name comes from its original application. Given a set such that the elements of S are forbidden to lie in a set AP Z, PZ modulo every prime P, how large can S be? Here AP is thought of as being large, i.e., at least as large as a constant times P. If this is not the case, we speak of a small sieve. Development. Large sieve methods have been developed enough that they are applicable to small sieve situations as well. By now, something is seen as related to the large sieve, not necessarily in terms of whether it related to the kind situation outlined above, but rather, if it involves one of the two methods of proof traditionally used to yield a large sieve result. Approximate Plancherel inequality. If a set S is ill-distributed modulo P, then the Fourier coefficients of the characteristic function are of the set S mod P are in average large. These coefficients can be lifted to values of the Fourier transform of the characteristic function f of the set S. By bounding derivatives, we can see that must be large, on average, for all x near rational numbers of the form a. P. Large here means a relatively large constant times S. Since we get a contradiction with the Plancherel identity unless S is small. Duality principle. One can prove a strong large sieve result easily by noting the following basic fact from functional analysis. The norm of a linear operator equals the norm of its adjoint, i.e., this principle itself has come to acquire the name large sieve in some of the mathematical literature. It is also possible to derive a large sieve from majorants in the style of Selberg. History. The early history of the large sieve traces back to work of U.B. Linnick, in 1941, working on the problem of the least quadratic non-residue. Subsequently Alfred R. Acute-NYI worked on it, using probability methods. It was only 2 decades later, after quite a number of contributions by others, that the large sieve was formulated in a way that was more definitive. This happened in the early 1960s, in independent work of Klaus Roth and Enrico Bombieri. It is also around that time that the connection with the duality principle became better understood.